Alright, so today we'll be talking about inverse matrices and systems. Now I know we've already talked back, I think in Unit 3 of last semester, about solving systems of equations using matrices, and we're going to solidify that with our understanding. So first off, I'm going to define it as a coefficient matrix times a variable matrix will always equal an answer matrix. Okay, now the problem is we don't know the variable matrix, so we have to do the inverse of the coefficient matrix to both sides and multiply it. Okay, and then times that by the variable matrix, and then times that by the answer matrix. Okay, now we all might not understand, but whenever you take the inverse and times it by the actual matrix, okay, you're going to get the identity matrix, and that's the multiplicative identity property of matrices. So this is going to be IV equals this. Okay, so this is pretty simple straight up. Now what also is going to happen is that I'm going to get the variable matrix, because anything times the identity matrix is just itself, so it's just going to be this. Okay, now I also know that in the past I have told you guys how to just go ahead and put that in the calculator. And I think we all understand that when you're trying to find the inverse of matrix, you can easily put it in a calculator, but I want to show you the methods. Okay, alright, so an inverse matrix looks like this. For a 2 by 2 matrix, 2, 3, 4, negative 5. Okay, so remember, if the determinant is not 0, okay, then the inverse matrix is 1 over the determinant times, now this one's going to be interesting, you're going to actually just switch the 2 and the negative 5, just like right here, and then the 4 and the negative 3, you just make them both opposite signs. And since they're both 4 and 3, we make them both negative 4 and negative 3. And then you just do the determinant of C, and that's going to be really quickly, easily, negative 22, and you just multiply 1 over negative 22 into each of these terms, and you would actually get some really funky looking fractions. So this would probably look like, okay, alright, and so what this would actually end up looking like is 5 over 22, this one would be 3 over 22, this bottom one would be 1 over 11, remember you reduce, not 1 over 11, 2 over 11, there we go, and then this one would be 1 over 11, actually negative 1 over 11, there we go. Okay, alright, so this is what it actually looked like when we get done working with it. Okay, alright, so nothing too scary to work with a 2 by 2 matrix. You can actually do this by hand. Once again, if you want to do it by calculator, put in your matrix and then identify this button. It's either in the matrix calculator if you use MetaMatrix or metacalculator.com, the matrix calculator portion. There's only 2 versions for it, so use either A or B inverse and just work with it that way. Now, the 3 by 3 matrix is a little bit more complicated. But what you would do is you would find the determinant of the matrix, okay, pretty simple. Then find the matrix D transposed, and there would be this button on the meta calculator. And then you would find the determinant of each 2 by 2 matrix. Okay, so you do the determinant there, do the determinant there, and you just work your way down. It's really, really quite interesting. Then you would represent these minor determinants as a matrix following an alternating plus minus pattern. So this would be plus right here, this would be minus, this would be plus, this would be minus, this would be plus, and this would be minus. I understand that I'm not really making the best signs for it, but here we go. And then you would just continue that on the way down. And then what you would do is you distribute the 1 over determinant of the D, and you could actually find your determinant. I find these steps all to be incredibly long for a process in which we could just put in the 3 by 3 matrix and then find the matrix inverse button. So you do what you will with it, but I strongly recommend that you understand the process for a 2 by 2 and you understand there are steps for a 3 by 3, but you don't have to do them. Okay? Alright, now a lot of you might be asking, oh wait, what does a transpose do? It actually switches the rows with the columns. So what it was a row before is now a column, and what was a column before is now a row. And it just kind of rearranges the whole matrix just to look different. Okay? Alright, and that's it for working with identity matrices. Oh, Nope, it's not, because I want to go back and show you. Now you know how to find this by hand, but now you can definitely do this equation with confidence, understanding that once you get that inverse matrix, you would be good to go. Okay, and you will also understand that if the determinant of this first matrix is 0, then you cannot solve that equation. So that's another plus on top of it. Okay, all right, that's it for inverse matrices and systems. I'll talk to you later. Bye.